while you are reading this problem, I'm going to go ahead and write this, write down one very easy integer root. X equals -1 is the root. That is, it's a value that makes the entire left-hand side equal to 0 upon substitution. So we know that it has at least one integer root. -1 is a proud member of the set of integers, right? And you can check that x equals -1. This part goes to 0 and this part goes to 0. So we do have at least one. Now we want to know how many of these integers in are there such that this has only integer roots. Okay, and it's a kind of a fun little problem because it kind of justifies or it's kind of a setup for Viețaș. Now notice if we take A and B, we'll go ahead and write down A comma B as members of the set of integers, and we'll call that Z's. Z, Zahlen in German, right? So A and B are integers. This algebra holds, though, irrespective of the set membership, okay? It could be complex numbers, whatever, okay? So x minus A, remember for every root, there's a corresponding factor. Okay, some people call these things zeros, but when you expand this out, look what you get. You get minus the sum of the roots in front of x, and this really is the justification for the quadratic Viețaș formulas. Okay, and you can just do this by hand if you don't want to remember that Italian name. Now, to get our equation of interest in the proper form, we divide through by n. Okay, so it'll at least look and smell like this, right? That's what I did right here, folks. I divided by n, and so it's fairly easy pickings from here. The whole point of Viețaș is to equate coefficients from two corresponding quadratics. Here's a quadratic, which is the equivalent form of our given quadratic, and this is the so-called Viețaș form right here. And so you see how we equate these two coefficients. That's all that's going on. Rather than memorizing those formulas, that's all that's happening, okay? So we know that 899 over n has to equal to minus a plus b, but notice that since a and b are integers, their negative sum also has to be an integer, right? Okay, but you see that begs the question, what kind of n divides 899? That would include negative and positive a's. Well, once you see that 899, and this takes a little bit of time, this is 31 times 29, a relatively large number being the product of just two distinct primes. It has a prime signature of, I think, 1, 1, something like that. But anyway, there's only, you can just write down the divisors here. The only divisors, if 899 is equal to 29 times 31, which it is, then the only divisors of n, and I'll write down divisors, the only n that would get the job done would be n equals to plus or minus the set, how should we write this? Plus or minus the members of this set, that would be 1, 29, 31, right? These are the only divisors, because this is almost a prime number, right? I think sometimes I've seen it called semi-prime. It even has an OEIS number. You know, it's amazing the whole thing about signatures. Okay, but if n is any of the numbers in this set, and there's 8 numbers in this set, 8 integers in this set, that necessarily will produce an integer here, but no other n will do that, right? Okay, so the answer would be 8. Okay, there's 8 such because you have to do the plus and minus versions of 1, 29, 31, and 899, the only 4 divisors of 899. So I like that problem quite a bit. And let me come on up here and how many such integers? The answer would be 8. Spell it this time for emphasis if I can. English spelling sucks. I don't see any long A's in there, but in any event. 8, okay? 8 integers with this property, and we actually know what they are also. If you wanted to know, there they are. Okay. All right, that's all.